So with that, we'll go ahead and get started. Thank you for joining us for the Demystifying Artificial Intelligence implementation. We have NetApp and we have NVIDIA. We've got a couple of great guys available to discuss this, and we'll just go ahead and start with the introductions, and then we'll work through some questions that we have, and we've got a little bit of a couple of visuals, but for the most part, we want this to be engaging, want this to be a Q&A. So again, feel free. So I'm KJ Burke, Solutions Architect Manager for Eastern Canada, and my focus is in hybrid cloud. So we try to help our customers leverage what they're doing in the data center, leverage what they're doing in the public cloud, and then wrap all of the analytics and management that really helps them succeed in both at the same time. And then we have Frank Holloman from NetApp. Frank, if you want to introduce yourself and just give a quick blurb about NetApp and AI.
Sure, I'm Frank Holloman. I'm the Senior Solution Architect for AI at NetApp. I appreciate the opportunity to be here today just to talk about what NetApp is doing to help customers along their AI journey, the solutions that we have and things that we can implement.
No, perfect. And then we also have Adam Shabinsky from NVIDIA. Adam, if you could introduce yourself.
Yep. So my name is Adam Shabinsky, as you indicated, KJ, and I'm responsible basically for the accounts here in Ontario, for the relationship of NVIDIA with enterprise accounts. We cover in NVIDIA, we cover a whole gamut of. You probably heard of us. Some of you know us from maybe gaming. Those who are more, I guess, in tune with what's happening in the IT world are probably well aware that we're doing a lot of stuff with AI, with data science in general, with providing and building and designing infrastructures to provide the right tools for those teams to be able to do their work. But also, of course, in the domain of virtualization, VDI, what we call virtual GPU capabilities, and also in the professional graphics. So we're used in rendering, in M&E in general. And so we cover a lot of topics in a lot of various domains, but I guess nowadays we're predominantly known as the AI company that applies AI in all of these various domains.
Yeah, and I think that's we'll talk about it a bit today, but really, the partnership with NetApp and storage being so important to how IT teams help deliver AI solutions. So definitely, so we'll kind of get into that. So really quick from a CDW perspective, this is something I very much enjoy, getting in front of customers and having these conversations and trying to bring, the best of the industry really to have putting them in front of our customers. But our goal is to be this leading IT solutions and services provider. And in part, that's helping educate our customers. In part, that's helping bring good people to the table. So I don't want to belabor this, and I'll kind of zip through the next couple of slides, and then we'll jump into the questions. So, yep. So I don't want to give away too much of that. I'm going to stop sharing. And let's just kind of jump into the questions. So when we look at AI, we look at the challenges that IT teams have servicing AI. What are some of those common challenges? And this is for both Adam and Frank, but we'll start with Adam first. When you're helping IT teams work with their AI application owners and the business, what are some of the common challenges that you see, helping IT teams service that part of the organization?
I think when we talk about challenges, there are a number of challenges and a number of different levels. So maybe we should start with the most fundamental level, is that often we find ourselves in a situation where we need to explain and illustrate to the various teams, be they AI teams and in some cases also data science teams, that in order to do AI, in order to implement AI really, what you need is first and foremost the tools to be able to do so. And those tools are typically divided into, I would say, three primary domains. You need a lot of data in order to be able to execute those, to be able to build your AI models. You need the right algorithms, which is where data scientists, AI researchers, and so forth come in. And perhaps what's more relevant to the people here in this particular group is the fact that you also need the infrastructure. The infrastructure can be cloud-based, it can be on-prem, it doesn't really matter. Either way, you need the infrastructure. And the infrastructure for AI is inherently very different than the infrastructure for traditional compute. And this is where we start seeing some issues. Traditional compute was great for what we call general purpose compute. But when you come to do AI, which is very dense compute, you're doing a lot of matrix multiplications, a lot of linear algebra, a lot of parallel computations, you require a very different kind of infrastructure. We call it GPU compute. There's different names that were given to it. And it's part of the reason, obviously, that NVIDIA is the number 1 player in that field, is because of our heritage in parallel compute, also known as GPU compute. The parallel compute basically helps to overcome one of the limitations in traditional compute systems, which is the serial nature of the computations, and the fact that Moore's law has kind of declined and reached a point where you don't really see much in additions to performance. The fact that you need a different computational infrastructure, be it in the cloud or on-prem, it doesn't really matter. You need a different computational infrastructure is something that a lot of people have to wrap their heads around, and it causes a lot of friction. And KJ, if I have another moment, maybe I can cover some of the frictions here, because the key friction that we see again and again and again, and this is something that's probably well worth mentioning, is the fact that in the end of the day, the data scientists and the IT people see the workload in a very different way. For data scientists, the workload is all about GPU servers that create, or GPU compute that are basically computation engines. They solve problems, they provide answers, they enable you to put in an input, which is data, and get an output, which is some sort of an answer, a model, some sort of a response or inference for the original input. The more compute you put, the more compute you throw at it, the more instances you have in the cloud, or alternatively, the more compute you have on-prem, the better. Faster results, of course, for the line of business people. Faster results increase competitiveness. They bring higher profits. They lower the overall costs of the system or the environment. The data center managers or the IT people see this kind of compute, on the other hand, the GPU compute, the dense compute, in a very different way. When you come to a data center manager for a dense compute system, is basically a heat system. Heat system that you install in the data center, and it generates lots of output in the form of heat. You put in electricity, you get a ton of heat on the other side. You've got high-power servers, high-power dense servers that are put in racks that in some cases are not really designed to accommodate dense compute and high-powered compute. So there's always a sense that they represent a certain risk to the environment, because all my environment is X and this is Y. And then it creates a certain amount of unpredictability around power consumption. It can create a certain, in their minds at least, a certain unpredictability around heat. And because of all that, there's a certain pushback, almost a knee-jerk reaction against installing these kind of systems or adopting these kind of systems on scale within a data center, even though they can benefit the organization as a whole. So these are kind of the challenges that we typically see on the day-to-day if you're looking at IT.
And I think when we look at part of what we're trying to accomplish today is really help explain some of that value, so that the IT owners that are listening, they can better understand, okay, well, what is the value that the business is getting out of it? But so Frank, I mean, when Adam's talking about all that additional compute and how NVIDIA GPUs are leveraging that, fundamentally there's some challenges around data. And so if you could kind of speak to data and how IT, what are some of the challenges IT has around servicing the data that compute wants to consume?
Yeah, the point that Adam brought out about having to rethink compute when we start talking about AI is extremely true. And from the data side, as Adam pointed out, that as you get bigger and bigger and bigger, more complex models, the data sets get larger and larger. Um, you have to start thinking of what the infrastructure to support this is really going to look like. Because when I talk to customers and I really break it down very simply it breaks down into two pieces. What I call the math part, the computational piece, and then the non-math part is how do we feed these voracious data eaters that are called GPUs, and so with these large data sets. So that's where it really, when we talk to IT people, let's talk about one, what are you trying to accomplish? What are the answers? As Adam mentioned, you're asking a question and you're trying to use AI to get an answer. So we have to understand what is it you're trying to do, but then understand, more importantly for us, where do you want to do it? Because most AI journeys start in the cloud, because if you don't have the data set to support the questions you're trying to answer, you want to fail fast, right? Fail quickly. But then as companies go along their AI journey, they don't necessarily stay in the cloud. Some will say, hey, we've adopted an all cloud model. Great. Some will say, no, we want to move this back on-prem. We're at a stable situation where we want to now bring it back on-prem. Great. And so that's the challenge, I think, for IT infrastructure is how to be supportive along that timeline, because it's all about being able to support the data needs, the ever-growing data sets, and how to transform along with what the data scientists are trying to do. And to me, I think that's the biggest challenge that most IT people, true IT people, are trying to solve, whether they work in traditional IT or they're working in the business unit that's doing the AI work.
Yeah, no, absolutely. And I think, you start to touch on, I think, our next topic, which is really around, the data science pipeline. And so the first part of that is really, how can we help IT organizations, or how can we help our IT customers bridge the gap with the data scientists? And so Adam, when you're talking and you're dealing with kind of the gamut of, like, you're dealing sometimes with the IT teams, and sometimes you're dealing with the data scientists, the application owners. Where can where can our IT customers better understand the data scientists that they're trying to service, and what insight can you give them to help build some of that communication?
Yeah, well, that's that's a very good question. Like you said, it ties into the challenges question very nicely. Um, in the end of the day, what we aim to do is to make everything as simple as possible for all teams, be it the data science teams or the IT teams, the data center teams. For the data science teams, we create tools, we build processes, we create libraries, software, a whole bunch of, call it, software-based infrastructure in a way to enable them to build the best tools. For the data center people, we have a similar approach. Obviously, it's not going to manifest itself in a GitHub where you download stuff, although it can, because there are certain tools around MLOps, around the operational aspect of how to maintain this environment, which are software driven, and we do provide as open source tools for data science center guys to be able to manage and monitor their environments. But more specifically, when it comes to the actual infrastructure, or how to consume it, how to build it, how to maintain it, how to plan for it, how to budget it, we have what are known as reference architectures. So in other words, they are pre-vetted, predetermined, not so much recipe book as almost appliance turnkey solution approaches that we propose and we build together with NetApp to deliver these ready-made infrastructures. So if you have a stakeholder that's sitting in a company X and they require GPU resources for a particular team, all they need to do is they need to say, we need for this amount of GPU compute for these teams, and they are able to receive an entire BOM that includes every single aspect of that infrastructure, exactly what it consists of, down to the piece of software, the storage associated with it, the cables, the networking cables. Every part there is pre-configured, predetermined, and importantly, pre-tested. So these systems are already being built, they've been tested in real world against a variety of use cases, and this is the optimized version that is proposed, and everything is packaged up. And CDW, you guys offer all these reference architectures in a beautiful way to the customer. And the idea is that from the moment that a customer makes a choice that they need X amount of resources within their data center, they can, within a couple of weeks, 3-4 weeks, they can be up and running with that environment. Not 6 months, not a year, not too much planning, not too much head racking of how we do it. Everything is done. Everything is at a turnkey approach.
Yeah, and so we're going to come back to that because I think one of the key things for IT teams to understand is architecture matters. And we very much have gotten into a commoditized workload world where a lot of our data center, it's a bunch of virtual machines running on some commoditized hardware. And that's kind of the way we view a lot of IT now. But realistically, with these types of solutions, architecture does matter. And so I'm gonna circle back to that in just a moment. But before we go there, Adam, can you just give us the 2-minute version of the data science pipeline? So I'll put up a visual that you can speak to. But really, the idea here is oh, when you talk about that workflow that that the application owners, the data scientists want to take advantage of, how can we as IT experts really tie in and talk to the data scientists? How can we support this data science workflow, this pipeline?
And this is, once again, it's a very good question because it enables even people that are not doing data science to kind of understand what data scientists really do on their day to day. And these are the three main. If you look at the top part of the graphic, you'll see three main domains that data scientists touch in the workflow itself. Everything starts, of course, with data preparation. So the data preparation is the cleaning, the structuring of data for training. So you need to get the data ready. And by the way, when we say get the data ready or data preparation, includes, of course, ETL, it includes accessing the data on the data lake, it includes all the processes that are data heavy. And by the way, the processes that would rely on storage and the transmission of data from point A to point B the most. And also, I would say data preparation from a percentage-wise, these things are represented as three groups, but data preparation is actually the group that consumes anywhere between 70 to, in some cases, 90% of the time and the resources and the effort for the teams. It's the most important part. So here the data scientists will have to come and select what data they want to actually use, figure out where the data is, in what form the data is, how do I clean up the data, how do I take unstructured data, turn it into structured data, in what way do I choose to do it? And the whole pipeline, by the way, is iterative. So I'll get to it in a moment. The next stage after you prepare the data is to do the actual training. Model training is basically the learning and the building of a model from the data. So I'm creating a model using the data. Because keep in mind, anything with data science and with deep learning in particular relies on data as an input. The data creates the model. And then the model is created as a product of feeding the data into the model. The model becomes what it is. And then I take that model after I finish training it, which can be time consuming, but nonetheless not as much as data preparation. And I want to visualize the data. I want to have a way of interpreting the results. I want to improve the accuracy on the next iteration. I want to be able to see what I'm missing. What should I change? Are my results in line with my expectations? Are the results really meaningful to me? And if not, which in most cases they will never be on the first try or the second try or the third try either, because it's an iterative process. So I'll look at the results, I'll figure out what needs to be changed, I'll go back to the data preparation again, I'll reselect data or make changes to the way I'm preparing the data, the way I'm selecting the data, or the type of data I need, and I'll run it through a model training again, and I'll look at the results, and I'll make a correction. And the whole thing is a loop, and in an iterative loop that you're improving again and again and again. And the loop itself is something that is continuously applied simply because in the end of the day, the business needs may change. So therefore, the model itself has to continuously improve, change, or be altered in order to fit a changing business landscape.
Yeah, and so this is where, I want to bring Frank more into the discussion because you know it's important, I think, to understand that it's a continually improving model. And so it's not sort of the traditional we built it and they consumed it. It's, as you're pointing out, we built it and then we went back to square one and we refined it and then we refined it again. And even if it's not refined on the same, um, they do an iteration and they choose, okay, well, this is good. They're going to come back to that model later. They're going to want to improve it, and then that comes back to data. And so I guess, so Frank, when we're talking about this data science pipeline, how can IT teams really architect this platform that the data scientists are going to consume, and how does NetApp help build that platform and really focus in on the data because as Adam pointed out, the model's being created from the data.
Yeah, and that's important because when we look at this, the two things that, as I mentioned earlier, it depends on where you're doing this learning program. Is it in the cloud? Is it on-prem? And then there's another piece that we look at that when you start cleaning the data, as Adam mentioned, there's also the process of collecting. A lot of times, AI is not a fixed data set. It's an ever increasing data set. A classic example, easy example, is self-driving cars, such as Tesla's been doing for years, of having cars send back data. So there's else can be an increasing amount of data when we start talking about IoT of things. So we have to look at where's that data coming from? How are we going to replicate or move that data to the location or locations that the data scientists want to be working in? So we start talking to customers about, okay, how can you have a flexible infrastructure that can handle both at the edge of data collection and replicating that back, having it at the core infrastructure, or doing it in the cloud, moving back to core, or then using cloud as it's, the traditional thing when people talk about cloud. Well, yeah, a lot of people use cloud to handle busy parts, whether it's a certain time of the year or in a company's case where the sync up happens to parallel where everybody's trying to update a model at the same time. Well, we don't have enough resources, so we're going to temporarily go to the cloud and that kind of environment. So having a data fabric that NetApp can provide to handle each one of those situations is really the key to not getting stuck into a corner wherein somebody said, no, you should only do it on-prem. No, that just doesn't work. So that's the thing that we look at architecture is, yes, you want to keep it as flexible for any one of those scenarios as the data modeling and the execution of this data pipeline keeps changing.
Yeah, and so you and Adam both touched on something there as well, and that's that the data is going to grow. And so really when NetApp is looking at this data fabric, and NetApp is trying to help customers really consume the data where they want to. How can NetApp help with the growth of that data, both the management of the growth of the data, but also again that sort of explosive having to have more and more capacity, but also having to have more and more throughput, because just because your data set doubled in size doesn't mean that they want the model to take, twice as long to run, right? So
yeah, as I mentioned earlier about, the great thing about what NVIDIA has been doing is these really spectacularly engineered GPU systems. And when you look at that and we say, okay, we've got to handle this increasing, when I say the data eaters, increasingly with these larger and larger data sets. So we look at it from the perspective of how can we seamlessly, what I refer to as a utility model, that the data always be available. Because when you ask a data scientist, they really don't care what the infrastructure is, most likely. They care when it doesn't work, right? They can't get an execution done. So you need to look at how can we do this? How can we do this like a utility where it's always on? that we can add. We can scale vertically, we can scale horizontally, and we can do that non-disruptively, both on-prem and in the cloud. And so that's where NetApp really comes in and is helping customers to solve that ever increasing data size problem, the problem of where do we need to do this, and to be able to scale in a manner that we can keep up with the GPUs that are just getting faster and faster.
Yeah, no, and so I'm going to throw a bit of a curveball at you because we had a question that was submitted, from the attendees. It was earlier through email. Um, what about at the edge? And so when we talk about, the solution, including inferencing at the edge, how does NetApp approach edge data? And really, when you talk about that data fabric, how can we extend the gathering of data, and how can we extend the storage of, say, inferencing models at the edge?
Yeah, when we look at that, when someone asks me that, I always want to make the clarification when they say AI at the edge, that if we're talking about true collecting a little bit of data and making a decision, doing an inference, that's where products that such as NVIDIA has that does that particular piece. But when you're talking about in a scenario where we're collecting, I have a customer they're a pipeline company, and they collect just an ever increasing amount of data, and this has been going on for years, even outside of AI. But they're increasingly collecting more and more data about the pipeline. And so they're having to do that at remote facilities, and being able to not have to have a different style of infrastructure to support that at the edge, but then be able to scale that from a sizing and performance standpoint, and collect that data at the edge, but to be able to seamlessly replicate it back, whether it's at the core or in the cloud, where we start talking about AI, now we start talking about having that data there that's available for modeling and the testing that's being done by the data scientists.
No, absolutely. Okay, so thanks. And Frank wasn't prepped on that question, so I that was great. So then, again, as these systems are growing, as the number of devices we're trying to manage grows, as the complexity goes up, I think really one of the things that's important is this, reference architecture and this platform, because there's so many tools in the space. And so, Adam, when NVIDIA looks at that platform, and NVIDIA is looking at, automation and orchestration, um, where does NVIDIA focus, and how does NVIDIA bring value around that infrastructure as code, and really trying to help IT organizations leverage Git as opposed to having to manage everything individually?
So this is absolutely key. This is one of the two fundamental things. So first of all, you need to create, as you said, a reference architecture to enable people to actually deploy these systems. And then on top of that, when the systems are actually deployed, you have to have a good way to manage them and to monitor them and to automate them. So now we're focusing obviously on the latter, and within that domain of automation and orchestration, there are a few what you call fundamental realities. And the fundamental realities are that in its essence, an AI workload, both on the inference side and on the training side, which are the two separate workloads, you actually touched upon that in the previous question with the edge. Edge would tend to be more of an inference, and the data center would tend to be more of a training kind of scenario, although not exclusively so. But within the context of either of these, there are certain fundamental truths and certain fundamental realities, and those are that you're going to be using or leveraging, most likely, a containerized environment. There are other ways of working on the training and the inference side, but there's nothing as efficient and as effective and as a standard too nowadays as using a containerized environment. So for containerization, you typically would look at Kubernetes as being the leading platform for containerization. So that's the first fundamental thing. So you're going to be working with some sort of a containerized solution. The second thing is you're looking, and this once again draws from the reference architecture itself, when we talk about reference architectures, we're also talking about highly optimized systems within those reference architectures. So NVIDIA, part of the reference architectures are the NVIDIA DGX systems, for instance. The DGX systems look like servers. They are built somewhat like servers, but they are, just like I showed the pipeline of the data science before, we have data preparation, model training, visualization, and it's an iterative process that goes around. NVIDIA approaches the hardware in the same way. We build hardware, and then we use it ourselves, our clients use it, and then we see how well it fits and what needs to be improved, the better, more tuned results for this particular workload. And we go back to the drawing board and we create the next version. And now we're in a version, in fact, a fourth version of the DGX, a highly optimized system. So when we're looking at automated tooling, for instance, how do we use automation? The actual DGX systems themselves contain within them automated environments, both in the hardware and in the actual OS level of the DGX itself. And I'll give you a few examples. We have a numerical format called TF32 that enables faster training. We use a special interconnect called NVLink between GPUs and memory, and then we have special NICs that are 200 gig HDR NICs that are mapped on, or they exist in the ratio of 1-to-1 with the GPUs. So we've got 10 of those in every single system. So these are systems that every component in the actual system has been designed from the ground up to provide an automated high level of response. So when the data scientist comes to run something on a software, automatically behind the scenes, what is happening is that it gets translated into or mapped onto the hardware in a very sophisticated manner to enable the highest performance. And then we have automated tools, actual tools for building and deploying the clusters as logical units. We call them DPOPs. We have an EGX software stack for the edge, the DPOPs for the state data center. And these are a collection of open source tools that you can go on a GitHub and deploy. And as long as you have the right kind of resources, you can create these optimized logical units of performance. And finally, and this perhaps is something that is more relevant to the day-to-day of the IT professional, is that we have a special program called DGX Ready Partners. So vendors that create, call it an OS that overlaps these systems. So I'll give you an example. There's a company called Converge.io that NetApp and NVIDIA have validated and for the reference architectures. And you apply the software and it enables you anything from running and orchestrating the jobs automating the process of the training itself with a click, with literally everything is done through a web UI, all the way to enabling managers of IT and data centers to see at any given moment what the utilization is on their cluster, who's using what resources, how much resources are they using, where do I have bottlenecks, where do I have potential heat issues, all of that in one single pane of glass. So all of these are tools and systems that NVIDIA provides to enable higher levels of automation and orchestration.
Yeah, and then so NVIDIA has layers of automation and orchestration, and I think one of the things you mentioned there that I didn't bring up that's key is visibility. And so Frank, when you look at NetApp as part of the reference architecture and building this, I'd like to talk a little bit about sort of infrastructure as a code and how NetApp brings that. But then I also want you to talk a little bit about Triton and what Triton sort of brings to the picture as well.
Yeah, because Adam brought out a good point is when you look at AI infrastructures now are being run in containerized environments, one of the things that we've been working on and have had available for a while now is what we call NetApp Triton. And that is it's a software that's supported by NetApp, but it's open source, it's out on GitHub, but it allows you to control and manage persistent storage in a Kubernetes environment. And that's become extremely key because again, as these data sets get larger and larger, and when you start talking about having an environment with multiple data scientists running multiple experiments, it becomes very, very effective if you can use the underlying technology of the infrastructure to make what you would traditionally call, IT would call a gold reference, a gold standard reference of a deployment. And so you can do the same thing with now, here's a data set that we know we're going to use for a specific model. I can replicate that and try and make use of that, the underlying technologies now to make that available in a containerized environment. So now there's no more, I have these large data sets just because somebody wants run another experiment with that data set. I can do that all in persistent storage and not actually have to copy the data and make multiple copies over and over again. So it's the integration of those things into a containerized environment with things like Triton that really makes it cost effective and easy for the operational aspects of doing AI. Because as Adam mentioned earlier, getting the models out. I mean, we look at it that AI is you're producing a product, whether that's internally or externally for customer use or internally. It's help you get that to market faster, and being able to do those things inside with Triton in a containerized environment. Those are the keys that are going to make people successful.
KG, you're mute.
Sorry about that. I was coughing. I apologize. No, I think you definitely hit on some good points there. And data management in a container-based environment is very tricky. And so having NetApp have an open source solution that they are helping sort of pioneer in that is great. So absolutely. So we're starting to get towards the end of the hour, and again, I just want to reiterate, anybody on the line who has questions, if there's something that we touched on that you would like to have further discussion, feel free to put that in the Q&A or in the chat. We're here to help answer some questions. If you're not comfortable with that, we can come back to it at a later date. We want to engage after this webinar. We're happy to work with you and really identify what your needs are. But Adam, when we sort of focus in on so how can NVIDIA really help deliver on these solutions for their customers? And so we've talked about a bunch of stuff, but if you could kind of summarize, in just a couple of minutes, how can NVIDIA help IT teams, make these platforms a reality for their business owners, right?
I think the most important way that they can help is the fact that we have all these reference architectures. So let's say a customer wants to deploy a particular infrastructure, and I alluded to it previously. All they really need to do is try to define what the workload in question is. From that, extrapolate, and this can be done together with us, together with NetApp, together with you guys, extrapolate how many resources they're actually going to need to consume. Maybe they are already consuming resources in the cloud and it's becoming a bit too expensive, so they want to consider what does it look like from a cost perspective, from an operational perspective, what does it look like to map whatever they're doing in the cloud now and to scale it up on-prem, or to create an on-prem alternative, or maybe an on-prem augmented environment for the current workload. And in that case, it's just a matter of determining what kind and what scale of resources they're going to need. And then there's a reference architecture that maps to that. Like I said, it's almost like a turnkey solution. The moment you assess and ascertain how many resources you're probably going to consume, it's very easy to come up with all the specs of what's exactly needed in a data center, how much cooling, how much heating, how much electricity, how many racks, where does it sit, what does it look like, creating rack elevations. All of that is a matter of literally a couple of days, and the client can know exactly down to the dollar how much it would cost, how much it will cost to operate the environment, and how long it will take to deploy it. In addition to that, all these environments are highly scalable. So you don't really have to hit it on the nail. You don't have to get it exactly right. You need to get it approximately right. And then if you need to scale up in the future, not a problem. You can scale up in a building block approach, where every time you add a bit of resources, compute resources, storage resources, almost like you would do with an HCI. So very, very, very similar to that kind of an approach. We have white papers, we have the reference architectures, We have the engineering teams. But here's the thing. I think our real secret weapon is the fact that we are a partner-oriented company. We only work through partners and with partners like NetApp and certainly CDW, our number one partner in Canada. And the partners become our secret weapon because in the end of the day, CDW have got a ton of experience in deploying precisely these infrastructures. So you guys, KJ, have deployed it in so many organizations now. I can't even. The list is extremely long. So you have a vast amount of experience in deploying this yourselves, in-house experience. NetApp has got a tremendous amount of experience in deploying and helping to create those reference architectures with the storage aspect, with their own software stack and how everything ties together. And this is where everything becomes a really clean, cohesive solution where you know that everything is available, the professional services are available, the delivery is available, the solutions themselves are available, and the most important thing is that everything that I just mentioned is extremely cost effective too.
Yeah, no, I think and you're right. It really does become this platform, and again, I keep coming back to um, the way that the architecture is done and the way the infrastructure is built truly matters in these solutions. And so Frank, coming back to NetApp and really how NetApp helps, drive ease of use for their customers and helping IT teams really deliver this. I think it's important for our customers that are on the line here in the webinar to understand it is possible. You can do it. There are blueprints. There are partners that can work with you. So if you sort of summarize what we talked about with NetApp today, how can NetApp help our IT customers, really deliver this for their internal, business owners?
Yeah, it always goes back to the flexibility of what you're what you're gonna have to do to support what your company is doing in AI, and the flexibility about that, and having these reference architectures that can be applied to multiple scenarios of edge and core and cloud. And the other thing that we're doing internally is to try to help customers understand as these infrastructures get more and more complex. We're actually using AI ourselves for the data that the infrastructure sends back. We're constantly looking at that from an AI perspective, and have AI models that are looking at the data we're collecting of how the systems are running, and both try to do predictive analysis of making sure, again, in that utility model, the system never goes down, but also to help customers do best practices of, hey, we've analyzed, and if you did this, you would be more effective, you would be more efficient, and how data gets stored, and your footprint, and what that would be to, because you're doing more with less, which is kind of something a lot of IT departments constantly hear. You're going to have to do more with less. So, and we try to do that with our active IQ environment to help customers in those situations.
KJ, I think you're on mute.
Darn it, I'm on mute again. I'm sorry. So it's horrible. I've been managing other things anyway. So um, no, I think that's good. I think that again, it's tools like Trident that NetApp's made available. It's the orchestration and automation that helps us do more with less, and hopefully it's not less. Hopefully it's do more with the same. And the question I'll pose here at the end kind of comes back to that. And I've done a couple of AI conversations, and this question comes up each time. But I want to talk a little bit about what CDW brings to the table, and so hopefully this shows it correctly. I guess I'm kind of in the way there partially. Let me go here. That's not going to work either. Okay, so so my role at CDW is really to help manage the team that oversees sort of this distributed cloud, and so we focus in on hybrid cloud, and a couple of areas within hybrid cloud where we specifically work with our customers is around connectivity and portability. So as Frank mentioned, it's that portability of data, it's that portability of the workloads and the applications that are running, that helps free you up to operate on premises. It helps free you up to operate in a public cloud where it requires that. And so that's a unique property in how you build things and how you architect things and the types of solutions that you use. Hybrid cloud management. So again, being able to manage and automate and orchestrate across those different cloud resources, whether again they're private cloud or public cloud, and then those real-time analytics. So those are some of the areas where we dig in with our customers to help them try to smooth that over. And where that's applicable in the AI conversation we just had as Adam and Frank pointed out, sometimes you're going to want to be operating on premises, sometimes you're going to want to be operating in public cloud. And there are tools that NVIDIA has available. There's tools that NetApp has available, like Data Fabric, that help allow for that portability and help allow those insights and that management across those different platforms. And then the foundational areas that we focus in on, I'm not going to talk a ton about security, but we do a lot of security services for our customers. And get back into, from a data center focus, really where we sort of cover AI is in these specialized applications. And it really is important to understand that architecture in these systems does matter. It is a challenging environment to put out there, but with the right reference architectures and working with the right partners like NVIDIA, NetApp, and CDW, we're able to help you really build that per plan, and where you need to make modifications, we're able to help guide you through those modifications. But we are happy to engage around AI. We also do a lot of HPC, and so those are both areas where we can offer. And then when we talk about in the public cloud, again, containers and microservices, application modernization, and the automation and orchestration. So again, you know, you're probably going to be working in a Kubernetes type containerized environment. We are happy to engage on that. So I don't want to beat that dead horse, but we are here to help engage. We are here to help get to that next conversation. And so really, where we want to be able to focus in with you is what are your goals and objectives? And Frank is a great resource from the NetApp side. Adam's a great resource on the NVIDIA side. As you kind of listen to this, as you take this back to your teams, we're happy to engage. We're happy to have that next conversation with you. And again, we're trying to sort of demystify things, but we understand that this is a process that takes time, and we want to have you, our IT customers, really be able to focus on integrating with the business, helping support them, and really we want to help bring that message to those business members, and help arm you with the knowledge that'll help you be successful. So I didn't notice any additional Q&A or anything in the chat, but I do have this other question that came in, and so I'm going to go ahead and answer it last, just because. But Frank, what do we do when AI takes over the world? So the question is, when do you foresee the workforce starting to shrink as AI and automation starts to take over? And then I'll ask Adam the same thing, but how do you see that going forward?
I, I may be wrong, but I don't see that happening. And the reason why I see that the human intervention in processes is still going to be there. That and medicine is a classic example. We're doing more with in AI for medical and medical situations where when you analyze something on a microscope slide, AI is being used to do that more effectively and efficiently. But there's still usually a human that has to say, yeah, that is the diagnosis. So I think you have to look at it in that perspective, that we'll be using AI for a lot more things that helps be from a speed, efficiency, and showing a perspective that the human may not have recognized, but the human kind of gets to do a different job, not necessarily no job.
Yeah, I kind of come to the same thing. But before I answer, Adam, when will Skynet go online? Which version of DGX will run it?
Yeah, well, I don't know if that's first of all, let's kind of separate between two forms of AI that we tend to overlap with each other. There's the current forms of AI, which are models that are specifically designed to do X. So they have a model that is specifically designed to do facial recognition under certain circumstances for certain types of workloads or outcomes. You have an autonomous vehicle that's supposed to drive a car. So that these are the models that are specific. They can be created from an amalgamation of various models that each one of them will do a particular thing. If I talk to Siri on my phone, I have probably 5, 6 different models that are working in conjunction to deliver a particular result. Nonetheless, none of it is intelligent. So that AI is not taking over anything. That AI is used solely for one thing and one thing only. That's optimizing a particular domain. So if I'm looking at doing radiology and I want to identify cancer growths better, that's a particular domain that's being optimized. And there, this AI is delivering real value today in a variety of domains. And we're finding more and more and more domains in which to deliver value, and more sophisticated models to deliver more and more value. So that's the one form. Then there's the AI that people know from the, I would say, the general AI that people aspire to, and that people know from the science fiction and the action movies, the Skynets, and that's a general AI. When it comes to general AI is a bit like quantum computing. It may happen, but it can take 50, 60, 100 years before we see that happening. Either way, general AI, even when general AI arrives, and it probably is a matter of when rather than if, but when that happens, and it can take a long time, literally potentially hundreds of years, but when that happens, it's not necessarily a bad thing, and it doesn't necessarily inherently mean that AI is going to take over our lives. What we could more likely end up with, probably in terms of the likelihood of the scenario, this is the more likely scenario, is an age of plenty, where AI takes over the management of stuff that humans are just not good at doing. So humans are not good at building economic systems. We have, for instance, the invisible hand of the market, where the assumption is that every participant in the marketplace, the economic marketplace, wants to optimize their particular outcome, and therefore the invisible hand of the market will kind of stabilize and create an equilibrium within it. As an emergent phenomena, but that's not always the case, and we can see that. So we see that markets, for instance, tend towards optimization, and as they tend towards to becoming more efficient, they become more brittle. But humans are very bad judges of when you should trade off resiliency for efficiency, and vice versa. And AI, on the other hand, that can see all the different moving parts and has maybe an outcome or a directive to create an outcome that is more optimal, may decide that the trade-off, the point of equilibrium, where society wants it to be, for instance, and by controlling all the various aspects of a supply chain, is able to deliver a much more efficient result for society. So AI is not necessarily inherently negative thing, even in its what you call ultimate form, the general AI form.
Yeah,
So that's a long.
No, it's valid, and that's where I kind of come back to the AI that we're talking about today. The amount of data that's needed, the amount of computational effort that's needed, again, just to create a model that can look at an X-ray and call out abnormalities so that somebody can take a closer look at those. That is a huge amount of effort, and so having a general purpose AI that can make decisions with all sorts of different data feeds. Yeah, you're right. I think we're a ways away from that. Um, but something that was really interesting to me in understanding kind of what we're doing with AI is, the average radiologist or X-ray technician is looking at around 1,000 X-rays a day. And if artificial intelligence is able to let them focus on the 50 to 75 of those that they really should be spending time on, because there's a high probability that there's abnormalities in those, that's really going to improve the quality of life of people that are having to go through cancer screening and things like that. So I think when I look at the AI that I'm seeing, what my customers are talking about doing, about the systems that are being implemented, it really is focused on, how do we be more effective? How can we use this as a tool to augment our decision making? So again, it's not an AI that's making decisions, it's an AI that's helping the people make decisions. And so yeah. One more thing, for attendees, we will be sending out a short survey. The survey is really, just to help us get better. We want to continue to improve. We want to continue to make sure that we're bringing good content. But then anybody who returns that survey, we're going to be putting in a drawing for one of these Introduction to AI in the data center training vouchers, and so that will just go out, and we'll communicate that via email. But I want to thank everybody who attended. Reach out to your account managers. We can follow up and we can have additional conversations. I really want to thank Adam and Frank. Really appreciate the conversation today, guys.
My pleasure.
Thanks. Have a great one.